Okay, apparently we're live now. All right, everyone. We're going to give everybody a minute or two to come in. And Christian, hello. Good to hear from you. There you are. All right, while we're waiting for everyone to come in, we had a question about parts 1 and 2 and where to find them. I don't actually have the URLs because my job is just to show up and talk.
Hey, Nick.
Yes, ma'am.
All right, I found them real quick. They are on our channel. If you go back a couple pages, part 1 was February 18th, and part 2 was March 18th. So
I was just going to say, just do a search for Mirantis and you'll find them on there.
Yep. If you go to our channel page, search for Kubernetes is what I did. They should be recorded. You should be able to access them. Again, those dates were February 18th and March 18th.
So there you go. Okay. That is today's producer, Lisa Wallace, and she is much more efficient than I am. All right. Anyway, so I think we are ready to get going. Christian, can we hear you now? We cannot hear Christian. Well, Christian is with us in spirit. So let's get started. Let me go ahead and share my screen real quick here. Go into presenter mode. And apparently I can't be in presenter mode and do this at the same time. This is an interesting interface that they have here. So let me share my screen and we will go for it. All right, everyone. So good morning, good afternoon, good evening. I am Nick Chase from Mirantis, as always. And we are here for today's webinar, Getting Started with Kubernetes, Part 3. Today, we are going to be working with storage. As we were just saying, parts 1 and 2, part 1 was just sort of an introduction to YAML, a general introduction, and then we talked about creating specific objects. Today, we're going to talk about actually getting into doing something, which is awesome. So let us move forward. I'm going to stay out of presenter mode here for reasons that will become obvious as we go along. But as I said, I am Nick Chase, Director of Technical Marketing and Developer Relations here at Mirantis. I'm a former developer and writer and just general agitator. You can get hold of me at nchase@mirantis.com or at Nick Chase on Twitter if you like. A little bit of housekeeping. You can go ahead and submit questions in the questions panel. We will keep most of the questions for the end, I believe. And then at the end of the webinar, the recording will be available. So you do not have to ask the question, will we be able to get a recording of this? So you don't need to take notes. There will not be a quiz later unless you really want to. And then, we can make that happen. What we'll be talking about today is the basics here. We're going to talk about the basics of how storage works in Kubernetes, including some simple storage, some things that are not actually storage, but they're different purposes for volumes. And then we're going to talk about persistent volumes and stateful sets, which would be how you actually build an application in a cloud native environment that doesn't just go poof when your workload goes away. So let us move right on to the beginning. All right. So the basics. We are going to look at all of the different ways that, well, not all of the different ways, and you'll see why in a minute, but we're going to look at the basic ways that you can use storage. So when you have a pod, okay, and as you can see here, we have a plain old pod. You typically do not have any particular storage except for what's part of the image. So if you want to actually do anything, you're going to want to create a volume. And the simplest volume that you can create is an empty directory. Okay, so let's take a look at exactly how this works. So I've got a pod, I've got my container, typical stuff, name and image, but within my container, I'm creating a volume mount. I'm giving it a name, and I'm saying where it is within the container. All right, and then I'm referencing, I'm sorry, blah, 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 blah. It's early in the morning here, so you'll have to excuse me. But when I say giving it a name, what I'm saying is I'm actually referring to the volume that we've defined down here. So we've defined the volume as Redis-storage, and we said it is an empty directory. Okay, and we're saying we're putting it at data/Redis. So let's see how that works. All right, so I'm going to go ahead and I'm going to grab this text, and this is why we're not in presentation mode. I'm going to come over here to my text file, and I am going to, I've just put it into a YAML file just so that I can easily run it. I have Lens. If you haven't used the Lens Kubernetes IDE, I highly recommend that you do that. It's a simple tool that lets you get at everything that's within your cluster, and it gives you an easy way to get a terminal that will lead you directly to your cluster. So in our case, I'm going to say kubectl create-f, and live.yaml is the file that I'm going to be using. All right, so I've created this pod. All right, it's pretty simple. I've got it up and running. I can open a shell. So now I can go inside this pod. In this case, I only have one container, so it's just it's the one container. Now let's see where we put our storage. It was at /data Redis/Redis. So if I go to cd Redis, I can see I have a directory here. I can also see that it is empty. Okay, I can put, let's just say echo hi to file.txt. Okay, now I got my file. If I were to get out of here, come back in, ls Redis. There's my text, my file text, my file.txt. Okay, now here's the thing about empty directory. It is, as they say, completely ephemeral. So if I were to delete this pod, okay, all right, so it's completed. It's going to go away in a second. And then I were to recreate it. Okay, so now if I come in and I recreate that pod, my container is recreating. Okay, I'm going to come back in, look at the shell, ls Redis, nothing. Okay, so empty directory is really only for working data. Okay, it's not persistent at all. All right, so the next step up from empty directory would be hostPath. Now let's look at hostPath. hostPath is really only going to work for you easily when you have a simple cluster with just a single host. Okay, a single node rather. So let's see how that works. So in this case, again, I've got my pod, I've got my container, I've got my volumes being defined down here. Now, in this case, I've got two different kinds of volumes. I've got a directory, in this case, var local demo on the host, and a file, var local demo data.txt, on the host. Okay. Now.
Hey, Nick.
Yes, ma'am.
Quick comment. People are having a hard time seeing the text. If you could zoom in a little bit. I know you're switching between screens, but it is hard to see.
Well, let's see what we can do. Let's see what we can do.
Thanks.
Tell you what. Thank you for that. Let's bring it over to here. And do that. Hopefully that will make it easier for everyone.
Yes, it looks good.
Looks better. All right. So, all right. So that's not what I want. I want this. There we go. Okay. So again, we have our, see, this is why we have a producer, guys, because I can't do this and watch the comments at the same time. All right. So, right. So we've defined these. We've defined our mount paths. In fact, our mount paths are where they are within the container. Okay. So I can just say var local demo-ish. Okay, so let's say demo-ish. And you'll notice, again, we're referencing the volumes that we had before. So let's see what we got. All right, so if I say that, run it in Lens. Okay, already exists. Let's get rid of the old one. How you know it's live. All right. So now if I go into the shell, and again, we're looking for var local demo-ish, cd var local demo-ish. All right. So if I see here, I've got my data.txt file. All right. And I'm going to go ahead and let's see here. Let's say echo hi again to another file.txt. Okay. So now it's there. If I were to remove this pod, okay, the pod no longer exists. Here in our pod, we're not in our pod definition, we're not referring to that file in any way. Okay, all we're referring to is this directory. Okay, so if I were to come back and recreate that pod pointing to the same directory, and it could be a different pod as well. I'm just not changing things for the moment. If I were to go to that var local demo-ish directory, cd var local demo-ish directory, there's our extra file. So any pod that we create is going to see that because we've made changes to the actual node. Okay, that's what we get with hostPath. Okay, as our volume type. All right, so those are the two kind of simplest ways of doing this. Now, you do not want to use this for production applications, okay? Because again, this is only for a single node, and once you go, if the pod was on a different node, that would be gone. So that's not going to help you. All right, so let's move on to our next state. So here we talk about persistent volumes. Now, can't see if we're here. Christian, are you here? Because this is I would love for Christian to talk about this.
Christian is online, but he's on the phone. I don't know if you can hear him.
Christian?
Can you hear me?
There you go. All right. Yes, we hear you. Okay, so Christian, speak up, and I would love for you to tell them what you were telling me yesterday about why you need persistent storage and how to implement it and what's so important about it.
So, first of all, I come from a world where enterprise storage was king, NetApp, EMC, all the major storage vendors. Then storage shifted from hardware, from filers that you would buy, to software-defined storage, and this brings us to Ceph that we use for persistent storage on Kubernetes, also for other products, but this is a backend that we chose for Kubernetes. There's a number of reasons to that. One of them is that Ceph is extremely scalable, that it is very safe, it keeps data safe very well. We have had customers trying to sabotage Ceph environments intentionally, and provoking data loss is very difficult. We have flexibility. We have a system that can do multiple things, multiple protocols, that is able to do both persistent storage for Kubernetes, an object store that may be needed for your Kubernetes application. All of this is it's sharing the same storage backend. This is a big advantage of other storage backends that do only one or the other, and so you would have to have multiple storage backends. So, of course, stability and reliability and data protection are the most important things that you will have, and this is something that this is essentially why we chose to use Ceph. So how does Ceph work? We have an internal storage protocol named Rados, which you as a user never see. You can see protocols that this internal storage protocol is translated to. One of them would be Rados block device, RBD, which we are using to create persistent volumes for Ceph. So if you put data into a Ceph cluster, it is automatically replicated. You are only writing once, and the item is internally replicated by the Ceph cluster itself according to a set of rules that Ceph provides for this purpose. You can choose how many times it's replicated, whether it's replicated on a node basis or a rack basis, and you can provide different. You could even do erasure coding, but I would not recommend that with block storage due to performance considerations. So normally we see a 3 times replication, which is sufficiently safe even for business critical data, and it is still manageable from the number of replicas. So how does this work in Kubernetes? Ceph is essentially what you do is, to create a persistent volume. A persistent volume is created in Ceph, and then it can be attached to the Kubernetes environment with as a persistent volume claim.
Right, and we're
do you have a demo for this?
version of that, just so that everybody knows. And by the way, I'm so sorry, I forgot to introduce you, Christian. Christian Hubner is one of our extraordinary system architects here. So, and he specializes in storage. So sorry for not introducing you at the beginning. Go on.
So, Nick, do you have a demo for this?
I do have a demo, yes. Not
Okay,
a,
maybe we
a demo of how persistent volumes work.
Oh, okay. Then if we don't have a Ceph cluster, I'm going to just describe this in theory. It's essentially the way that you use persistent volumes in Kubernetes is the same regardless of whether you are using another backend or Ceph. So you can have the advantages of having a Ceph backend without having to change anything in your environment. The Ceph cluster, of course, needs to be available. A key needs to be provided for security, and then you can attach a Ceph RPD volume as a persistent volume to your pod.
All right, great. So let's see a simplified version of how that process works. Thank you so much, Christian. I appreciate that. Christian is in the realm of the real. I do the sort of toy applications, but Christian has seen what happens when many terabytes of storage are at risk, and how to keep them from going bye-bye. All right, so Christian was just talking about Ceph and how it provides all of this replication for you so that you don't have to think about it. And this is what you're going to see. You're not going to see any of that. We're not going to talk about replication for the most part, not on the back end anyway. As you can see, there are lots of different kinds of persistent volumes that we can have within Kubernetes. But let's take a look at kind of a simple example. So as an administrator, and Christian, this is where I get a little fuzzy. So if I say something wrong, feel free to jump in on me here. So as an administrator, you need to create a volume that can be worked with. And that's typically done through a storage class, which defines sort of what is the driver. As a computer user, you're probably familiar with drivers that run your hard drive or your video or your mouse or whatever. So, yeah, go ahead.
I wanted to answer that question about the NFS share. There is no NFS shares in play here. What we are talking about are block storage volumes. So basically, each of those persistent volume claims gets its own volume. So there is no crosstalk. There is no access problem with this. This is essentially like attaching an iSCSI device and having different LANs to create storage block volumes. The same thing happens in Ceph. So there is no risk of, there is no problem with NFS and crosstalk.
Excellent. Thank you. Thank you so much. All right. So let us look at creating a persistent volume. So the first step is we got to create a persistent volume that we're going to attach to. And I'll pull it over here so we can see it a little better. All right. So let's look at how this works. So we're creating a persistent volume. All right. We gave it a name. We're setting the specs for it. Okay. We're just going to make it a small one, 10 gigabytes. It's on the file system. Access modes, read write once. That means that only one node at a time can connect to this particular volume. If you set it to read write many, then you can have more than one. Reclaim policy, deleting all the information on it. In this case, we're doing something simple, so we're just going to use local storage. Okay. We're saying where it is, and we're defining how you know what node it's going to be on. Okay, so we can take this and we can go ahead and create, whoops, let's see. and we can go ahead and create this persistent volume. All right, so let's get to the right window. There we go. Okay, so we can come over here and see it under storage, persistent volumes. All right, there it is. Now, we can also go ahead and create a persistent volume claim. Now, this is how we're actually going to get at, excuse me, at the data from our pod. So we want to claim some storage. So if we come over here, we see how much we want. Again, access modes. Now, if I come over here and I create this persistent volume claim, so here it's created, but you might have noticed I didn't actually specify a persistent volume to go with it. So Kubernetes created one for me. And there it is right there, 17 seconds. All right, it's our storage example PVC is the claim that goes with it. So you have that option also. All right, and then how do we actually use that from a pod? So let's come over here to our pod. Too many windows. There we go. So we've got our pod like normal. And again, we are creating a volume mount and referencing the volume. And in this case, the volume, instead of being empty directory or hostPath, we are saying, okay, we want this persistent volume claim, and we're referencing it by name. So we can then come by here. Keep forgetting, got to get rid of that pod. By the way, if you're wondering why I'm not just using apply so that I can keep changing it, there are only certain fields that you can change using apply. Otherwise, it just complains at you anyway. So, all right. So let's take a look. All right. It's pulling up my container. Waiting. What are we waiting for? There we go. Okay, so we're good. And we can come in here, go into the shell. All right, so var www HTML. Excuse me, my goodness. And if we go there, we don't have anything there right now. So let's see. Go ahead and add some text. Let me see if I can make this bigger here. Apparently I cannot, so I apologize. That's a little hard to see. But, so now if I look, I've got this here. So that's on my volume. If I kill this pod, and recreate it, and then if I look at, if I go ahead and look at that directory again, let's see what happens. So if we go, all right, where were we again? var www HTML. Okay, so cd var www HTML. Okay, there's our file. you know, cat index.html. Hi. All right. So any other pod using that volume is going to see that information. So it's not gone. And as Christian was saying, if that volume is managed by Ceph or some other system that includes replication and data protection, that data is protected. I don't need to worry about it. And the other thing is, I can build my application just using this plain old local storage volume claim, and then change the volume claim over to use the Ceph volume, and everything should just work. All right. So let's see where else we go. Oh, here's another one that I wanted you to know. Now, this one's subpath. This is kind of an interesting thing that you need to keep in mind. Subpath is useful not because it gives you a subpath on your pod, on your container. It does not. Let's look at it. So in this case, I've got a container. I've got an environment variable. I'm pulling this information dynamically. Okay, pod name, value from field ref, field path name, metadata.name. So basically, I'm pulling that. Okay, and image volume mounts just like normal. Okay, name. So this is the volume I'm using. Where am I putting it? Logs. Where is it on the host? Var log pods. However, this subpath expression is actually going to create a subdirectory. Well, let's see. Let's see what it does. Okay. So if I come over here, I don't come over here and I create my pod and I look and I say, all right, I'm going to shell in there. And if I go to cd/logs and I look, there's no subdirectory there. Why not? Because we're not creating the subdirectory in the container. We're creating the subdirectory on the host, on the node. So in this case, it's not actually going to be at var log pods. It's going to be at var log pods, more complicated example. Now, why would we do this? We do this so that if you have multiple pods or multiple containers or multiple anything, they can each have their individual subpath within this host path. Okay. So this basically maps to that. Okay. Let's see. Time 11:35. We are right on time. Okay, so let's see. Coming back here. So a couple of other uses for volumes. The downward API is a useful thing. It is used for basically getting information into a container. Okay, I'm including it here because it's a volume, but it's not really storage. I mean, it affects your storage within the container, but it's not what you would think of when you think of persistent storage. So let's see how this works. Okay, got my container, mounting my data at cpodinfo, and I've defined my volume. Now the volume is using the downward API, and it is pulling these items. Okay, well, the path is where it goes within the container, and then we have the data that's coming in. So in this case, we've got metadata labels. Okay, metadata labels and metadata annotations. Well, let's see what happens when we run this. Okay, so here, let's get out of that so it doesn't yell at me. I don't want to get yelled at. It's too early in the morning to get yelled at. Okay, so downward pod, we go to the shell. So where did we put this? Etsy pod info. So if we look at Etsy pod info, we've got annotations and labels. Okay, so if I do, okay, so ls annotations, it's just a file. So more, let's do cat annotations. We can see the data that was, I think I've got them backwards. No. Okay, we should, oh, no, there it is. Okay. There it is. It's just no line feed. So we've got our information there. And if I do the same thing for labels, so cat labels, there are our labels that we had referenced here. So it's a way to get information into your pod from your YAML. This can be really useful if you're, say, dynamically creating these YAML files, or otherwise programmatically creating these through the API. That can be very helpful to you. All right. Next. Secrets. Okay, so talk about passing information into a container. A lot of times you've got things that you literally want to keep secret, like passwords or other kinds of information, and we'll see, we'll see what kinds of things those are. So, for example, you've got arbitrary data, Docker config files. These are the different types of secrets that exist in Kubernetes. So if I were to go ahead and create this basic secret, this is just sort of basic authentication. Let's take a look at it. So kind is a secret. We just named it. It's pretty simple. We're just specifying the type. And then we've got the data, the username and the password. So let's go ahead and create it. And then we can see that that shows up under secrets. So there's our secret basic authentication, username and password. Notice that these are in clear text. This is in base 64. You can change this in Lens, but that's just a Lens thing, so never mind. All right, now, how do we actually use this? So, oh, by the way, this is a sort of more complicated version. This is like the Bootstrap token. So you can see the different types of secrets have different types of information and work differently. But we're just going to go with the simple one for now. So in our case, pull it over to where you can see it better. All right, we've got our container, volume mounts. Again, it's the same as we've been doing all along. We've got our volume, only this time it's a secret. And the secret name is secret basic auth, which is what we defined, right there. Okay, secret basic auth. I know it's really small. I'm sorry. I don't know how to make it bigger. All right. So if we go ahead and create it, helps to save the file. There we go. Back up here to pods. And we look at it. Where were we? Etc foo. So cd etc foo. And there's our password and username. And you can see the information is there. Okay, we're just looking inside the files. All right, we're in the home stretch. So now we've got all that information, but how do we actually create an application that uses persistent information easily? And here's what I mean by that. We've talked about creating pods that are specifically going after persistent volumes or other types of storage space. But in general, Kubernetes is designed to be stateless. It is a cloud-native environment. It's a stateless environment. If you kill a pod, it should be able to come back anywhere and work perfectly, which is all well and good until you're trying to run a database. And then all of a sudden, maybe not so good. So one thing that Kubernetes has, which is extremely useful, is a stateful set. So I'm going to take just a couple minutes here and talk about stateful sets. So the idea here is you're creating pods like normal, but you are creating sort of generic names that they can be accessed by rather than IP addresses. And when they die and get recreated, their state stays the same. So in this case, I'm going to go ahead and I'm going to create a service. This is the service by which we're going to access this. I'm going to do a website using Nginx because, you know, why not? So I've got my service. Let me create that. And I've got the actual stateful set itself. So let's go ahead and grab that and put it in our text file. So let's see how this works. So I'm referencing the service name that I just created. I'm saying I always want there to be 2 replicas. Right? I'm specifying the selector for those replicas. Say, okay, anything that's got the app equals Nginx is part of this stateful set. And then, like in a deployment, I'm creating a template. Okay, and so I've got my metadata, again with the labels, and then the containers, okay, specifying my containers, my ports. Now, volume mounts, this is the part we came for, okay. Volume claim templates, metadata is www is the name, okay. This is what we're referring to, whoops. And we're saying where it is in the container, and we're giving the spec for the storage that we are requesting. All right, let's see how this all works when we do this. All right, so if I come in, we're going to create that stateful set. All right, so now I've got one container. It's coming up. They're created in order, so you don't have them all created at the same time. So the second one's not going to be created until the first one's finished. So let's just come over here. You remember what I said earlier, we are trying to we're trying to give them specific host names. So let's see if each container actually has its own host name. So let's take a look here. I'm just going to run, basically I'm going to execute in each of these containers, what is your host name? That's all I'm doing with this. So I'm going to come to the terminal and do this. And yes, they do. Okay, web 0 and web 1, they match web 0 and web 1. Okay. Now what, that's all great. Again, never, 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 never use IP addresses when you are working with a stateful set like this. All right, so let's see. Now, what if we want to write to these pods? Okay, so let's see what we got here. So let's say we're going to do the same thing, only we're going to write the host name for each of them as the index.html file. Okay, so let's do that. And so now once we've done that, so I can come in here to web 0. Okay, and if I look, and where did I put it? Okay, user share nginx HTML. So cd user share nginx HTML. Okay. All right. So there's our index.html file. So cat index.html. All right, web 0. Now, let's say maybe I don't like that. I'm going to say, let's see, echo Kilroy was here to index.html. Okay, so that's in there. Okay, now what happens if this pod goes away? All right, well, let's before we do that, let's come back over here. Let's look in the other one. Okay, so let's see. User share nginx HTML. User share nginx HTML. Fingers there. Okay, cat index.html. This still says web 1. Okay. If I were to kill web 0, so remember, I've killed one instance of this, but as a stateful set, Kubernetes is going to pop it back up and make sure that I've always got one. I've always got those 2 replicas, but not just any 2 replicas. These specific 2 replicas. You notice we don't have any random numbers here. We have web 0 and we have web 1. Okay, so when this comes back up, if I were to come in here to the shell on this, cd user share nginx HTML, okay, still got my index.html, cat index.html. There it is. Kilroy was here. So the changes that we make to the storage being used by this pod are persistent. Okay. And that, whoops, let's see. And that brings us to the end. That brings us to the end. So I'm going to stop sharing my screen here so that I don't like make everybody dizzy when I come back out to look at the questions. So if you have any questions, now is the time to drop them in the questions, to go ahead and ask them. So let's see here what we've got. Oh, I see there's like a whole bunch of questions that have already been answered. I have no idea what they were.
Yeah,
oh,
most of
people saying they can't hear Christian. Sorry about that. Okay. Yes, good. Okay, and also that the text is too small, idiot. Okay. Yeah. All right, we got that handled. Yes, good. Thank you for telling me that, because I will know that for next time. I'll be a little bit more prepared. Okay, so how can we get the slide deck / code used for the presentation? So the presentation, like I said, is live. You are welcome to email me at nchase@mirantis.com. And I will send you the slide deck so you can get the code. Just you give me a little bit of time. I've just come back from PTO and I am totally buried.
Hey, Nick.
Yep.
This presentation was also recorded, so anybody can go to the Bright Talk, our Mirantis channel, and you should be able to search for the recording. I don't know how long it takes to get posted there, as this is also my first one, but it will be available for people to download and rewatch the presentation as it was presented today.
Yeah, absolutely. I'm pretty sure. Yeah, I'm pretty sure that it's instant. I'm not 100% sure, but I'm pretty sure it's instant. But I think also that people are looking for the deck so they can copy and paste the text, because nobody likes to type, myself included, by the way. So there you go. Okay. Shouldn't we be using Vault to store secrets? Is this bad practice to store secrets in pods? There are varying degrees of how secure you want to be. If you're a bank, yeah, you probably want to use an external service such as that. I don't know if Christian is still with. No, Christian's not with us anymore. But yeah, so I mean, here we're kind of showing how they work. But yes, if you have very sensitive information, you are going to want to. You are definitely going to want to go ahead and grab a tool like Vault or some of the other tools that are out there. Okay, so I'm going to try and go back here. When you click on the shell in the pod created, how automatically kubectl exec comes and gets executed? Okay, that's a Lens thing. We actually have a couple of questions about Lens. So I'm going to go ahead and share my screen again. Let me pull up. Hold on. Okay, Lens. I'm going to share my screen again and show you. This is Lens, the Kubernetes IDE. So you can get it at kateslens.dev. Also on the Mirantis page, we have instructions for using it under downloads, although I understand that's going to change. But you can see getting started with Lens. So you can go ahead and grab that information, and it will show you how to use all this. I cannot say enough good things about the Lens tool. So definitely go ahead and grab it. Okay, let's see. All right, so Christian answered the NFS question. Okay, regarding persistent volumes, how do you deal with storage types that require kernel drivers to be installed? Okay, so the volumes are handled by Kubernetes itself. And so what you have to understand is at the level of creating the actual volumes, you're talking about the administrator and not the user. And so that is going to be up to the administrator to make sure that everything that you need is available. Let's see. Volume claim template reference, will it create new PV and PVC? I am assuming that you're referring to with the stateful sets. And yeah, handles all that for you. What about Kubernetes certification? Come to the Mirantis website. We have Kubernetes certification. That is what I can say on that. Mirantis.com. Let me find it while we talk. Training. Yes, if you go to Mirantis.com/training, you can take care of different certifications, and they will take care of you. Training.mirantis.com. There you go. OpenStack, Kubernetes, and Docker certification. Let's see, we got only a couple minutes left. Can one persistent disk be used across different availability zones, as in a different data center? I'm going to give you a 97% certain answer. I am 97% certain that the answer is no. I could be wrong on that, but probably not. I say that because I know that when you have different data centers and different availability zones, things are isolated, and for good reason. So probably not. All right, how to use different storage classes from GCE or Azure or AWS. As far as how to sort of instantiate them, each service is going to have its own documentation. But as far as how to use them with, once you've created the volume and you're using the persistent volume claim, it's exactly the same. So there are no differences. Do you have any video for Lens? Yeah, I would go to that kateslens.dev page. And that'll take care of that. How do you bind storage to AWS EBS? You need to check their documentation for that one. Since you are working closely on containers, thought to putting this question, you believe it would be mature to say that soon containers could be useful for use cases pertaining to huge amounts of data, like a data factory? Please share your advice. I do think so, but unfortunately we only have like 1 minute left, so I can't, there's not much I can say about this point. Let's see. Yeah, there's a couple of other questions. I'll see if I can get those put into a blog. No promises, but we'll see what we can do. We are out of time, but I want to thank all of you for coming. I know how busy everyone is, and it is wonderful to see you all here. If you want to see a part 4, let us know, and let us know what topic you would like to see. And with that, I want to thank all of you. I want to thank Christian for joining us, Christian Huebner. And also Lisa Wallace, today's super producer. So please,
you're kind.
So please join us next time, and we'll see you then. Thanks a lot, everybody. Bye-bye.